Let's see, I need to share my screen. All right, so here we are. We are going to use linear equations again, except we are basically going to be given word problems and we got to come up with the equation. And then we're going to solve formulas for specific variables. All right, so annotate. Where is that? There we go. All right, so let me go on to the next slide. All right, here's just a strategy for word problems. You've probably heard this 1,000 times. Read the problem carefully, more than once if you need to. We're going to let X or whatever variable you would like represent one of the unknown quantities. Then, if you have to, write all expressions in the terms of that variable X. And we're going to write equation, we're going to solve it, and then we're going to check to see if that solution makes sense in the problem. All right, so here are some key words that you need to make sure you understand. Sum, difference, product, and quotient are the four big ones. Sum, anytime you see sum, that means addition. Difference is always subtraction. Product is always multiplication. Quotient is always division. Some other things when you're talking about addition: more than, increased by. Subtraction, you may see the word minus, decreased by, difference between, subtracted from, less than, fewer than. Multiplication, we could use the word times. Product, percent. Multiplied by, twice, 3 times, 4 times, something like that. Division, they'll say divided by, quotient, or if you hear a reciprocal, they're talking about division at times too. All right, so here is basically what we are looking at. A number decreased by the sum of 5 and 3. How would I write a number decreased by the sum of 5 and 3? Well, sum means plus. Decrease, we're looking at a minus, and a number, that's our x. All right, so we are going to take x, and we're going to decrease it by sum of 5 and 3. Okay? I do have to put that 5 and 3 in parentheses because it wants to decrease it by that sum, so I want to add those first. So that's how I would write. Now, this is just a statement. This isn't an equation. Nothing to solve here. We could simplify that to x minus 8. Okay? All right. Here we go. Oh, I need a mouse. Six times the product of a number and 10. Let me clear this out. All right, 6 times the product of a number and 10. Times means multiply. Oh, that's not what I want. Multiply. All right. Product is also a multiply. I might want to use dots there instead of x's because I'm going to use my variable x right there in 10. So I'm going to multiply 6 times. I'm going to use a dot. The product of a number and 10. What is the product of a number and 10? That would be x times 10, right? Now, an easier way to write x times 10 would just be simply 10x. So I've got 6 times. I can also use parentheses and put them beside each other. 6 times the product of 10 and x. or 6 times the product of a number and 10. And that would simplify to 60x, right? Okay. Still no equation. Let me clear that. What we got next? It looks like I lost something there. Huh. I guess that's it. All right. So here is more of what we're actually doing. All right. Where we're given a problem, we've got to pull out the information we need. We need to set up an equation. So this graph shows the average yearly earnings in the United States by highest educational attainment. All right. So they've got it separated between statistics from male and female workers. The average yearly salary of a man with an associate's degree exceeds that of a man with some college by 4,000. So if you see here, this right here is a person with that dropped out of school before the 9th grade. Here's somebody that dropped out of high school. Here's somebody that graduated from high school. Here's somebody that went to some college but never graduated. Here's somebody that graduated with a 2-year degree. Then here's somebody that graduated a 4-year degree. If you notice, each time you get that next step, whether you're male or female, you make more money. All right. So somehow we're going to come up with an equation here. The average yearly salary of a man with a bachelor's degree or more exceeds that with some college by 40,000. Combined, 3 men with these educationals earn 191,000. Find the average yearly salary of men with each of these educations. So here is the question it wants us to do. It wants us to find the average yearly salary of men with each of these levels of education. And what were the 3 levels of education that they were talking about? Let me see if I can change colors so we can pull this out. They were asking for a man with an associate degree, bachelor's degree, and one that has some college. Okay? So what we've got to do is we've got to come up with an equation because we're going to add those 3 together and it's going to equal 191,000. Well, I can't just say X plus Y plus Z. All right, because that doesn't do me any good. There's nothing there to solve. I have more than one variable. So I have to compare these variables to each other. All right, it says I've got to figure out which one of these 3 I want to let be X. And it says average yearly salary of a man with associate degree exceeds that of some college by 4,000. So it is 4,000 more than associate. And then if you have a bachelor's, it exceeds that one of some college by 40,000. So the associate degree is more than some college. So what I'm going to do is I'm going to let some college be my X. All right. So some college, I'm going to put SC is going to be X. An associate's degree tells me it is 4,000 more than that. So that's going to be X plus 4,000. And then a bachelor's degree, it says it increases it by 40,000. So it's going to be X plus 40,000. All right. And then these three right here added together equals 191,000. All right, so let me see if I can find some room to write on. All right. So what we have is we're going to have X plus X plus 4,000 plus X plus 40,000 equals 191,000. All right, so now I've set up my equation. Now I need to simplify and solve. All right, to get rid of these parentheses, both of these parentheses have an understood 1 in front of it. So I'm just going to be able to add those together. That's going to be X. When I distribute, that's going to be plus X plus 4,000. And then distribute 1 there, that's going to be plus X plus 40,000. Then I can combine my X's. There's 3 of them, so that's going to be 3X. And then 4,000 plus 40,000 is 44,000. And notice that equals 191,000. So now I've got a simple two-step equation that we all can solve. I'm going to subtract 44,000. So 191,000 minus 44,000 is 3X is going to equal 147,000. And then I'm going to divide by 3. And X is going to equal 49,000. So what that tells me, X was my some college. So if you've gone to some college, you're going to make approximately 49,000. If you've got a associate's degree, it said it was 4,000 more than that. So 49,000. So for my associate's degree, 49,000 plus 4,000 more would be 53,000. You're going to make about 53,000. Notice what I'm doing is I'm substituting X back into what we let X stand for. And then a bachelor's degree said you made 40,000 more than some college. So that's going to be an average salary of about 89,000. All right, so that's how we step through that. All right, let's see what's next. That's pretty much all we're doing today is being able to do that, except for, okay, let me clear this off. Here's another situation. All right, it says researchers have surveyed college freshmen. So these are people that are 1 year older than y'all. Since 1969. The figure shows that attitudes about some life goals have changed dramatically over the years. So they compare him from 1969 students in college to the year 2010, which is still 10 years ago. So y'all were still quite young at this time. But if you notice, back in 1969, the first question off is, what's more important to you? What's important to you? How important is being well off financially? Back in 1969, only 42% of college freshmen said it was important for them to be well off financially, whereas in 2010, 77% of them did. So to people in college, it's gotten more and more important for people to be well off financially after they get out of college. Notice the other question was asked, in your years of college, how important is it to you to develop a meaningful philosophy of life? In 69, 85% of the people said that was very important. In 2010, only 47%. So as you can see, college students, as the years go along, are more worried about money and less about maybe being better people. or developing a solid philosophy in life. All right, so let's go to the question and see what they want us to ask. The percentage increased approximately 0.9 each year for the being well off financially question. And if this continues, by which year will all college freshmen consider being well off financially? What percent would be all? That would be 100%, right? So it wants to know at what point will this turn into 100% if it's going up by 0.9 each year. All right. So we need to come up with an equation. The equation is going to be in 2010, we're at 77%. So if we start at 77% and we add 9/10 each year, 0.9, our year is going to be our x because we don't know what year it's going to be. 0.9x equals, and we want to know when will that reach 100%. So now once we set that up, that becomes an easy subtract divide. Subtract 77, which is 23, and then divide by 0.9. And I am getting 25.55. X is about 25.55, which means in about 25 and a half years from when it was 77%, which was 2010. So basically, 2010 plus 25 years means by the time of 2035, pretty much all the people in college are just going to say it's all about money, about how much money they can make. Of course, never do 100% of people ever agree on anything, so this is probably a little bit off. But still, based on the problem at hand, that's what we're doing. Okay? So we're reading through stuff, coming up with an equation, and being able to solve it. All right, the last thing, I believe we're on to the all right, solving formulas for specific variables. So such as this right here, we got T equals D plus PM. I don't know what this is a formula for, but we want to be able to take a formula that has all different variables, and we have to be able to solve it for separate variables. Right now, it is solved for T. So what we mean is T is by itself. Okay, this is considered solved for T. If I wanted to solve for D, it would be real simple. I would just have to subtract the PM so that D is by itself. So whenever it's asking you to solve for a specific variable, what you're trying to do is get that variable by itself by doing just like you would solve an equation. So in this case, it wants us to solve for P. Okay, which P has been multiplied by M and it has been added to D. So what I need to do is I need to get P by itself. So the first thing is I need to get this term by itself. So look, I'm just going to subtract D from both sides. And then over here, you just write down T minus D. There's nothing we can do. You're just basically going to write down all the steps you're taking to get them by itself. And that equals PM. And then if I'm trying to get P by itself, it's been multiplied by M. The opposite of multiplying is dividing by M. And notice I get P equals T minus D over M. That's all we're doing. I had to subtract D and then divide by M. And that's what happened on the other side. Okay? Let's see if we have another example. All right, look at this one. This one's a little harder. We are wanting to solve for B squared, which has been added to B1, and it has been multiplied by H and multiplied by 1/2. So we got to do the opposite to get B2 by itself. So, and you sort of work in reverse order of operations when you're undoing, which means you're going to multiply and divide. Well, we're going to undo multiplication and division before we undo. Well, no, we do the parentheses last. Usually we do parentheses first. When we're undoing, we'll do what's in the parentheses last. That's what I'm trying to say. So I've multiplied the parentheses by h and 1/2. So to get rid of the h, I can just divide both sides by h. And I would have a over h equals 1/2, and then b1 plus b2. Then to get rid of the 1/2, I'm going to divide both sides by 1/2. Well, dividing by 1/2 is the same thing as multiplying by 2. So what I'm going to have is when I multiply this by 2 over 1, instead of dividing, I'm going to get 2a over h equals, this is canceled. Now I've got b1 plus b2. And I'm trying to get b2 by itself. Now I do the opposite. I'm going to subtract b1 from both sides. And now I end up with 2a over h minus b1 equals b2. And that's what's happened there. And I believe that is all we've got. What happened? Yep, that's it. So I'll go ahead and activate the next one. Plenty of y'all, a lot of y'all have plenty of other things to be working on, but everybody's got something to work on now. I'm gonna stop share. And then I need to stop. There it is.